Okay, Physics 11H, evaluation of data. All right, so we're going to talk a little bit about how to analyze the data that we produced in lab. So this is an important part of a lab write-up. I'll be making another video here probably tomorrow morning on how to write up the lab, so hopefully it'll be ready by the time you should be doing it on a remote in that 12:30 time slot, whatever it is at this point. Great handwriting here, evaluation of data. So in the lab, right, we had our position versus time graphs, right? We saw that it was linear, x versus t, it was linear. Now, I don't know if you remember or not, or if I really clearly said this or not, but the purpose of the lab, all right, you should record this somewhere, was to determine if a student can walk at a constant velocity. All right, determine if a student can walk at a constant velocity. We produced a nice, and well, what we said was, okay, if it's a constant velocity, if this position increases at a constant rate, meaning the slope of this line is constant. So remember, the slope of velocity of position versus time is equal to the velocity, right? We've said that in class a few times now. So yeah, we determined that, right? Just by looking at the line, we saw that the position was, or the position of the student is proportional to the time. All right, we saw the position is proportional to the time. That's kind of a weird way to saying it was a direct relationship between position and time. As time went up, position went up at a constant rate along with it. The experimental equation. So kind of the first thing we do is we state the relationship. It's proportional to time. It's a direct relationship. The experimental equation we get from the Logger Pro printout. Now, I just closed on my computer here off screen the video. So back in, actually, I wonder if you can see this or not. So this will be kind of goofy. But back on in the class, Physics 11H. Come on. Oh, great. Now it's going to glitch out of me when I don't want it to. Physics 11H, topics. In the Logger Pro resources, how to input data and make graphs. I actually used the data set from our class here, right? So I'm going to go towards the end, make a full screen here really quick. This is what I did before. All right. So we're going to look at the linear fit box here. What's in there? All right, so we did that in class, but I'm going to restate it here. All right, it gives you the linear fit. So it says x equals mt plus b. All right, x equals mt plus b. Well, that's cool. X is position. It's the variable that's in the y-axis. X represents the variable for position. M represents the variable for the slope of the line. It's a generic variable. We don't know what we know the slope of the line should be velocity, but we're going to take a look at that in a second. The x variable is time. B is the y-intercept. We'll talk about the y-intercept of this in a second. So rather than m and b, I'm going to go back and put the numbers in. And they're in that little box on the graph. This is not the same graph, but they're in that little fit line box. All right. So the slope of the line is 0. And we're going to round these to 2 sig figs. We're not going to write all 4 sig figs ever. That's just not scientific for this lab. we were not that precise in our timing, and we were not that precise in our placing of the cones to be able to say it's 4 sig figs, right? So there it is. The slope of the line is positive 0.81 meters per second. The y-intercept of that line was negative 0.18. And if you look at the graph, it basically looks like the y-intercept is 0. It's not exactly 0, but it's pretty darn close. It's, you know, far less than 10% of the maximum value. It's less than 5%. It's like about 2% of the total range of the vertical axis here of the position. So it's essentially 0, right? So this is approximately equal to 0. But it's not. We'll talk about that in a second. So what we do with this now is we try to figure out what these variables mean in our experimental equations. Well, the units here, meters per second, that's a speed, that's a velocity, right? So this is your experimental equation. So now we're going to define the slope here. All right, and kind of the way we try to figure out what the slope and y-intercept mean is kind of analyze the units here first. So the slope is meters per second. This indicates that it's a velocity. It's a velocity. The y-intercept, all right, has units of meters. It's a position, right? Really, it's the position when time equals 0 seconds. We give that a name. We call that the initial position. Call that the initial position. All right. We give these two variables, the velocity and the initial position, a symbol. All right. Velocity, we already have said that's a v. Initial position, we call it x with a little I. X initial. Glare is in the way. Sorry about that. X initial is what we call it. Alright, so that's the experimental equation. That's very important. We'll go back to this in a second. Well, actually, I'll go back to this in the next video. And then our initial position is that. What we do now is we write what's called the general equation. All right, so that's the experimental equation. That's specific to your lab data set, right? That is literally the experimental result of your data set. We know that this person moved forward with a constant velocity of 0.81 meters per second. All right, the initial position should have been 0. This is about 18 centimeters, so that's, you know, it's about that long on this, in my space right here, right? It's not that big, but it's a little bit off. Well, now we're going to write the general equation, all right? So we got to kind of remember what we just wrote. You guys can always go back. The general equation is what we have when we put this part in, this in our conclusion. You know, this is like the overall results of the lab, the general result. And we write the equation again, but instead of the numbers now, we put in the numbers, the letters, the symbols, the variables that we just defined. And this becomes our very first physics equation. All right? X, the position of an object, equals its velocity multiplied by the length of time it's been running for, plus the initial position. Really, that the negative, it shouldn't be negative here. The general form, you want to put the negative sign on there. This is saying the initial position was 18 centimeters behind where it looked like it started. That's probably due to not starting the time right, or starting it early, or starting it late. All right, if I thought about it a little more, I could tell you which one. Maybe you can tell me which one. So this is your first physics equation, all right? We're going to, in class or later on, rearrange this equation a little bit. and define displacement. We're going to define average velocity and so on, all using this equation. But this is really cool. This is our first physics equation. The position of an object, it's called a kinematic equation. All right, equation of motion. Q. It's an equation of motion. Constant velocity motion. You can tell if you know something's moving at constant velocity, you can always know where it is if you knew where it started and how long it's been moving for. You know, as long as you know the velocity. So that's pretty cool. All right, so save this. Tomorrow morning I'll make another video of how to write this all up. You're going to replicate this for your own data set, your own graph you picked, and have those ready to go.